So we were just talking about a lot of biological terms, the anatomical terms for the bones of dinosaurs and other animals. But now I want to swing back and talk about the other side of dinosaur studies, the geology. The course is Geology 307, and it recognizes that fossils are biological elements that are found in rocks, and they have a very specific time in which they were placed in there. And so the picture here is just sort of a standard field expedition. This is me and various students collecting fossils in Nebraska. And I go on lots of trips with students in various classes. Not this one, sadly. Certainly these online classes don't have it. Around the United States and even elsewhere around the globe to collect fossils. Let's talk about these principles. First of all, superposition. If you are looking at a stack of sedimentary rocks, uh, and here you've got a huge stack. This is Glenwood Canyon, Colorado, and you can see the layering. Look at the layers. Sort of watch the layer boundaries going from left to right across the screen. Superposition says that the oldest rocks are going to be at the bottom, and they're going to get younger and younger and younger till the youngest ones are at the top. And this is analogous to you sort of laying down a bunch of papers or books on a desk. Let's say you lay down a book on a desk, and then a few seconds later, you lay down another book on top of it, on top of that, on top of that, on top of that. And you could time all the things where you laid these out, and clearly the one at the bottom is the one that you put down there first. Now you could take those books and pick them up and slip books underneath and in between and mix up the order, but you can't do that with rocks. With rocks, they're laid down successively, one on top of the other, on top of the other, on top of the other. So time only goes one way with these rocks, from oldest to youngest, as top or bottom all the way up to the top. Now think about if you found fossils in here. If I found a fossil at the bottom of this cliff, it is going to be older than a fossil I would find in the top of the cliff or anywhere else throughout here. And so that is sort of inputting superposition and connecting it with where we find these fossils. Using the principle of superposition plus a whole bunch of other things. This is just the very first principle that we use. Geologists have created really their greatest creation, what's called the geologic time scale. It's a calendar of geologic time for all the rocks on the planet. And what it means is that you can go to a place like this, the Grand Canyon in Arizona, or you can be in China, Antarctica, England, Jefferson County, Wisconsin, and you can look at the rocks and you can place them on this calendar. We know by the ages of the fossils there and the stacking order what age they are, and we can compare these things. A little bit more about this calendar. Think about it. If you look at a regular calendar, you know that January always comes before July. So if you're born in January, and then somebody else is born in July, you are older because you came first. Same thing here. If I have fossils found at the lower part of this Grand Canyon, they're going to be older than fossils I find in these upper reaches. And then we compare the arrangement of fossils we find here with the arrangements of fossils we find all over the globe. You also hear a lot of numbers, and I'm going to give you a couple of numbers too, but you'll see statements like this. So this fossil here that you're looking at is a new dinosaur found in China, and it's 135 million years old. And probably in all of your various news feeds, whether you get your news from Reddit or YouTube or somewhere else, Facebook, a newspaper, television, etc., you would see that this is a common thing. We find a new dinosaur. As I showed you earlier, we're finding new ones all the time, and they'll usually tell you where they found it, what's its significance, and then they'll usually give you some numerical age. We do that as well, but we're not going to do that in this class. It's a little bit more detailed If you do want to know more, go ahead and read Chapter 3 in that optional textbook, just as a sideline. I won't be testing over specific things in there on this absolute time or numerical time. But also, I could encourage you to take Geology 204, Earth and Life History. It's also a GN class, and I've taught it for 20 years straight here at Whitewater. And we go into greater detail over the ways in which we identify rocks, identify ages, and then attach these numbers to them. Okay, I know what you want to know is, what do I have to know, or what do I have to learn to test, to take the test? What's going to be on the exam? All right, a few things. The time that the dinosaurs lived is what we call the Mesozoic era. If I've underlined it, it's a term you need to know. So that's the Mesozoic era. And we subdivide that Mesozoic era into 3 smaller time segments. That's like saying, all right, there's the winter or the summer as a time frame that we all know what that is. And then there's 3 months as part of the summer: June, July, August. So there's the larger term, the Mesozoic era, and there are 3 smaller time segments as part of it: the Triassic, the Jurassic, and the Cretaceous. And what you're looking at there, this is me, I'm in the red cap, and a few students from a few years ago, and we're collecting Cretaceous age dinosaurs in North Dakota. This would be from one of my Geology 492 field studies classes. More on these time terms. Besides those 4 terms on the previous slide, you need to know their orientation from oldest to youngest. So for instance, you need to know that the Triassic is older than the Jurassic, that the Jurassic is older than the Cretaceous but younger than the Triassic, etc., etc. You also need to know the numerical dates. And so that's going to be in the next slide. We'll talk about it in just a second. But then just another picture of me, the bald guy here, and a bunch of other students traveling to Texas and New Mexico to collect fossils. Texas is where I'm from. Done a lot of my research in Texas, and so I routinely take students to Texas and have students do research on Texas fossils with me. Okay, back to what you need to know. Here are this is part of the geologic time scale. Again, it's stacked according to superposition. The oldest is at the bottom and youngest is at the top. Now, Permian you don't have to worry about. Basically, you need to worry about, first of all, Mesozoic. That's the era, so that's all this green area. And notice the Mesozoic extends from the 245, and that is million years ago, to 65 million years ago. Those 2 numbers you need to know. These internal numbers you don't need to know. So again, if it's circled in red, you need to know it. The start of the Mesozoic, 245 million years ago. The end of the Mesozoic, 65 million years ago. And then the 3 parts of the Mesozoic: Triassic, Jurassic, Cretaceous. And all 3 of these, Triassic, Jurassic, Cretaceous, contain dinosaurs. Dinosaurs, we're going to find out, come along somewhere, not at the very beginning, but somewhere along the middle part of the Triassic. They exist in the Triassic. They certainly flourish in the Jurassic. Witness all the Jurassic Park, Jurassic World movies, etc. And then the Cretaceous is also filled with dinosaurs, but right at that line, at 65 million years ago, the last of our big dinosaurs disappear from the Earth. And this ordering of rocks, it's the same worldwide, everywhere. And again, if somebody's a Chinese geologist, an Argentinian geologist, a Russian geologist, they use the same time scale, the same numbers, the same words to describe these things. It's universal.